Hello everyone, in this video I'm going to show you how to create a tic-tac-toe game by using the new features in KorGE 2.0, in this case by using KTree. So let's get started. First of all, I'm going to generate the assets by a code. So I'm going to create a JVM class here that I can run here, and all the this is not going to be part of the game itself, but only for generating the resources. So I'm going to create a main here that I can run by using IntelliJ, and I'm going to create a 64 by 64 bitmap, and I'm going to draw something like this. I'm going to draw two lines, one here and the other one here. So this will be, and I'm going to store this right to current local here, and I'm going to store it in RCC because the current directory is the project folder. So on main resources cross PNG with a PNG, and I'm going to run blocking this. That's why I used the JVM main here. And now if this, here's the cross, this line and this other line, and I'm going to do the same for the circle, that this one is going to be blue. So this is going to be a circle at 32 by 32 with 32 as radius. Probably we will have to reduce this a little bit, so -3. So this is the circle here, it's not perfect, so -4 and something like this. And maybe we should do the same here to have smooth edges. Something like this. This code is not going to be, it's only for generating this, so this can be not as good as normally. So now we can create a KorGE KTree called Tic-Tac-Toe, for example. And here we have our scene. Let's use, maybe we can use 640 and 480 here. And now we can try to place here the images. For example, we can put here hello world, RCC, command main, resources, circle. So maybe we can place a board here And maybe we can create a container here. We have to improve this. And we can move. This is the row. This could be at 0, 0. So this is a row. Maybe we can create another tree for this. But well, in the end, this could be. Let me create another KTree with a row. This is going to be the container. So this could be cell 0, cell 1, and cell 2. And this is a row, and here we can, instead of using this, maybe we can add 3b ref, and we can add the row here. So this should be row 0, and we can duplicate this row 1 and row 2. And here we have this, and this. So this is our. Maybe we can rename this to just vote. And maybe we can center this somehow here. Oh well, let's keep it like this. And well, now we can use in our main function, we can now load this board KTree. And we can read the board like this, and we can add to our state, and we can execute the function here. So let's specify the same with an 8. And here's our board. We should be able to access the row 0 and cell 1, for example, and change the alpha to 0.5. So we have this, and we can, for example, maybe we can provide an empty PNG here or something. But well, in the end, we have the board like this, and let's support changing change cell. So we are going to provide the row and the column and the bitmap to use here. So this should be row and column, and now we can get the first view here. That should be this should be an image first unknown in the case it doesn't exist. Let's not fail. And we can change the bitmap to a slice of this, or maybe we can get the slice here directly. Okay, so now we should be able to, for example, we can read the cross bitmap with cross PNG, and then or bitmap cross and bitmap circle, and now we can try and maybe even an empty bitmap T, and we can create just read bitmap slice and slice here bitmap 32. So now we can perform this 0 1 and we can change it to cross, for example, bitmap cross. So here's the cross, and well, this is maybe we should, here in the board, maybe we can put some lines here, maybe a solid rect, and we can put some lines here. Let me make the grid the grid smaller. Maybe even smaller. And something like this. And something like this. So we have the solid rects here. I have an extra one here. I think should be 4 of them. Okay. So now we can run this again, and now we have this. What else? Maybe here in the row. Maybe what we can do is to create a new KTree called cell, and maybe here we can put all the things we want. For example, the circle and the cross here, cross, and maybe we can provide some kind of highlighting here, maybe something simple like a solid rect or so, with, and here maybe something like this, and this is the alpha, no, this is the alpha, so maybe something like this, and here something like this. Maybe we can force the width to 64 and 64 here, 64. And yeah, this is our cells, and now we can do the same. We can replace these images with cell with 3D references with the cell. So we can do this, and this should be cell 0, cell 1 and cell 2. And now we can just move this here, something like this. And our board is now using this. Something like this. Yeah, something like this. And then now we should change this. Instead of loading the resources here, they are already there. So maybe we can create an enum with the kind of cell we have here. For example, circle, cross, or empty, and then kind now here we have the cell itself, and we can access the cross and change the alpha or the visibility. Hidden, visible. We don't have visible in the Q view. Well, let's change the alpha to 0 and cross and circle and the highlight. So if the kind is cross, let's set the alpha to 1. The same goes here, and the highlight, well, let's create a get cell that returns a Q view, and let's put this code here. So this is a selector. Here we are selecting the cell that is this one, and well, now I can call this, and I'm not going to set, maybe set cell or cell set kind, cell set highlight, and I'm going to do the same here. So highlight. So this is the cell. So now if I run this, as you can see, we have all the things here, but if we change and set the kind to cross, for example, here we can see the circle now. The highlight is still there, but we can do this, and here's our board here. So now we should reset somehow the board. So this is reset. Let me put here so we can move them later. Reset the views, and this, instead of cross, we should set it to empty, and of course we should use x and y instead of 0. And here we have the empty board. And now we could set for this cell, we could get the view and then add some events here. So when over and out, we are changing the highlight. So this is our highlight, and then maybe when clicking, we can change the cell to circle or whatever. What I did wrong here? I don't know what happened. The alpha is not being used here. Here we have the alpha, but yeah, of course, because I'm changing the alpha not to this value but to 1 or 0. So we can use 0.2 for example, or use visible instead of the other thing. And well, this is a small sample for this. And well, the idea here should be to create a model as I did in other videos. So we have a Tic-Tac-Toe model or something like that, where we store the board with array 2 of cell kinds, for example. So 3 by 3, empty. So this could be a data class. I think this is a data class, okay. So, and then we would represent this model here by using commands and other things, but I wanted to show you how to use the KTree. So I'm not going to enter in this kind of stuff in this video, or well, yeah, now it has been like 23 minutes. If you were interested only in the KTree part, you can stop. But I'm going to implement the model and transform this into something better. So let me separate the model from the views. So from this model I can create a new model with a cell, change it. I'm going to move the kind to the model itself. So for example, with the x and y, we can specify a new kind. Tic-Tac-Toe. It was like that, or Tic-Tac-Toe? No, maybe like this. I don't remember, but I think it's written like this. So now I'm going to generate a new model by using the previous board and mapping x and y and v. Let's rename this, and this is generating a new map, right? A new array2. Okay, so if this would return a copy of it, and if cx matches x and cy matches y, we are going to set the new kind, and if not, we are going to reuse the previous value for that model. And something like this, I guess. Let me create a test here. Model test. Model test. And our test, for example, this is the empty board. Maybe we should be able to represent board we are mapping cell kinds to other values. Empty could be a point, stop, the cross could be an X, and the circle could be an O. This is this map cell kind to a character, so not a string but a character. So for example, if I create this model and set the center to cross, this should be probably something like this. Interesting. Cool. So yeah, this is here we are creating a new model, but maybe we could create a tic-tac-toe transition or state change. I don't remember how I used to call this, with a new model. And maybe commands here, class, data class, place chip, x, y, and count. So this could return, this could be the transition, could be a new model, old model, the new model, and a list of commands. So with this we can provide a way to set to change the views to a specific model, and then we can provide a way to to execute these commands to, for example, place the rows, the cells, and things like that. So this could be place cell, or place chip, or just place, and this will be a transition. Remember that this is going to be immutable. Even if this array2 is mutable, we are not going to mutate that, but to construct a new model. So here we are going to return the old model that is this one, the new model, and then we are going to place just one command for this place, that is going to be command place chip here. So this way, instead of a tic-tac-toe, we could implement other games and perform animations and things like that. In the end, the input events will just perform actions that will end producing commands that will be executed here. So we are going to this on click, that could be on up, that usually works better here. This is going to issue, we are going to have a model that is going to be initially empty, like here, and we are going to have a method to set the model, and setting the model is going to have this model, and we are going to use the x and y model board x and y to get the kind. We are not going to set the mouse event here, but only once here. Set the events, or register the input events, and here we are going to set the model, maybe even before here. So this is our model, and then we need a way to execute transition this place returns new model here, and this execute should receive maybe a transition, or just the list of commands. So with this transition, maybe this could be suspendable, or well, for now just a plain function. And the transition, we are going to iterate over the commands, and we are going to check the commands we have here, the place chip, for example, and this place chip is only going to change the cell set kind with the command x, command y, and command kind. So this is going to execute this transition, and here place x and y, cell kind, for example, cross for now. and this returns a transition, and the model we have here as a variable is going to be updated with this new model. So we are updating the model here, but also execute transition. We are also going to execute the transition here with this transition. Okay, so this is the event. Let me try. Not this, but this. So as you can see, this is working properly, but we have to do two things. We should toggle the turn here, the turn initially, for example, is the turn of cross, and then we change we toggle the turn. If we were cross, then it's the turn of the circle, and if not, we return to cross. So something like this. Right now, if I press here, this is changed, so we should somehow validate, maybe here or maybe in another place, that this movement is invalid by checking check valid cell, for example, and we are only going to execute if that's a valid cell. And this is, we are going to use the model, the board, we are going to use the X and the Y to get the kind, and it's only going to be valid if the cell is empty, and this is going to be valid only here. So here we are going to try to validate that the current model, the X and the Y, is valid, and we are only going to execute the command in that case, the transition. Now I cannot click here anymore, since this is, and the same goes here, I cannot click here. Okay, so this is this is working already. Now we should check the result of the game. In the case it is completed and it's used by, it's win or a tie or a lose from some of the players. So check win maybe, or check status, and then maybe check winner, or well, let me create game status. That could be tie, winner, or in progress, and here we should provide maybe a silk class game result. So we have a winner, kind, or maybe even player, and then we have a tie. Maybe even in the winner we can provide a list of cells, maybe the cells. We have the I point, or just point. This is a list of points or pointing with the winner cells. And in progress. So this is our game result. And here we should check that if this is in progress, or there is a tie, or there is a winner. So first of all, we are going to check if there's a winner by check row, maybe, or check line better, and in an x and y and dx and dy, and I'm not doing the test here, maybe I should, but well, in the end we are going to iterate 3 times, and we are going to get the both xy with the dx and dy. Let's put here so we check we are in bounds, but well, it's not necessary. In any case, if this is empty, if cell kind empty, if the starting point is empty, then this is not what we want. We want to have the same value for the start point, start value, cell value, we want each of these 3 values to be the same as the starting. So if it is not the same, then we are going to return false, and if not, we are going to return true. We could also use 0 until 3 here, then using this predicate we can verify that this is accomplished on all the cases. So pair it by n. So something like this. Or maybe we can check the same here with value is not empty. And maybe we can even return the cell kind. So when null, same line with same chips with all same chips, same chips, non-empty, or something like that. And if this is true, then we are going to return the start cell value, and if not, we are going to return null. So something like this, I guess. Maybe we can even put it here. Let's reuse this. And well, so here we could try all the directions, all the possible rows. We could generate the example. This would be 0 and +1. This would be the verticals ones, and until 3. So for the y +1 and 0, this would be the horizontals, and then we have 2 diagonals. This one and maybe this one. So 0, 0. Let me show you the board. So we have this. We have this. Okay, so the verticals would be, this is the y. Xn should be 0, 1, and 2. The y should be 0, so this. And the delta y, delta x is 0 and delta y is 1. So, so for example, here it will check this, this, and this. And for this one, it will check this, and this. And the same for the latest one. And for the horizontals, the same, but the x is 0 always as the start point, and then we are incrementing the y, and the delta is only the x, and the y is not incrementing. And for the diagonals is the 0, 0, that is this one, and we are incrementing the x and the y in the same amount, so it will check this, this, and this. And for the diagonal 2, it would be this point, the x2, 0, 1, 2, and the 0 row, this one, and the x would be decrementing and the y incrementing, decrementing and incrementing. So this would check this, this, and this. So well, if any of this is providing a result, we are going to result. I'm trying to figure out how to do this properly. So maybe we can provide with an if, or what else can we do? Here, in addition to provide the cell kind, maybe we can provide the list of items, the list of positions we have. In fact, maybe we can provide a winner result. Because here we have all the positions already pointing. So we can, for example, add the point int x and y, and here we can provide points here. This is going to be executed all 3 times every time, because unless this is not true, that could stop earlier, but we are only getting the points when all of them are executed. So yeah, this should be okay. And here I think we can use the let like this, because if this is null, this is going to continue, and if it is not null, it's going to execute this code. So maybe something like this should work, and this would return a game result winner. And here, if we check the board, we check all the, we have the cell kind here. If this is not empty for all, and we have not returned already, this is probably a tie. And in any other cases, the game doesn't have a winner and is not a tie, then this is in progress. So now let's create a test for this. Test winner, and maybe the empty board is the simplest one, and should be an in progress. And in progress. Placing a cross in the middle should be in progress too. But if we place for example in the y0 the 2, this should be a winner. In fact, let me execute it for it to fail, and this should fail. The winners should be a winner with the cross, and the list of points should be point int 1 and 2. And this is an in progress, so this is not working properly. So let me check only this asset. This is false. Maybe we can start with instead of with check winner, maybe we can start with check line first. So this is the cross winner model, and we can, for example, check the line at x1 0 0 and +1, and check that this is not an this is not let's check this is not null for now. This shouldn't be null, but now we can place a breakpoint here, and this should be true. So this is cross, this is cross as expected. Then let me check all the values in this lambda. So value cross, and it's not checking the rest of them. Here it should be the same as start set value and be different to empty. So now cross, cross and cross, and this is true. And we have the list of points here that is not the correct ones. They should be px and py instead. So now this should be working, and in fact it's working. And maybe we should provide a way to construct the board from a string. Operator fun invoke from a string. And I think we have a map here already for this. Map. I think we don't have the sources here. Yeah, I think I'm going to use this overload, I think. So a string, and the generating is char x and y, and if char is dot, we are going to, or else maybe we are going to use an empty, and if it's an x we are going to use cell kind cross and circle for the O. And now we can construct the model from this array, and yeah, I think now we can provide, for example, this instead of placing. So this is working also, and for example, let's provide a tie variant. I think this is a tie, right? This should be a tie. And this should be, for example, here is not, shouldn't be a tie. Okay, so this is working. Also, this shouldn't be a tie. Okay, this is a tie. This should be an in progress. and yeah, something like this. And now we can, for example, after executing the transition and with the new model, maybe we can verify the winner or the result. Check result. Test result. And perform things for different cases. In the case this is a progress, we are not going to do anything. But in the case we have a tie or a winner, maybe for the winner we are going to, let's put this result in a variable so we can use it. Here we can check the cells, and maybe we can set the highlight for that cell. And well, if the current, when we are pressing, if the result of the current model is not an in progress, or when it's a progress, we are going to do this when we're clicking. But if it's not in progress, we should reset. We should reset the model and redraw the model here. That will happen when we are in a tie or in progress. Here we could display a text or something. Let me try this. The run JVM. So this is a winner that highlighted everything. Highlighted the right things, but they were overwritten by these mouse events. So we should check that we are in progress to actually do these events. For example, here now this is working, and if I click here we restart the game. Let's force a tie. This is a tie. We are not highlighting, but well, this seems to be working somehow. And maybe we can put a text here. Let's increase the grid. And maybe we can provide a text here. And cross wins. And name game result. So here or maybe we can set the text to empty, and here the states. here we can set the result player wins and tie. Cross wins. Game result. Game result. This is somehow not working. Let me check. Let me put a breakpoint here and try to figure out what's going on. Because game result text view, maybe. Or maybe the set text only works for the old texts. This contains the text, so it seems that this set text is not working here, but we can get this and then set the text to empty. Container set result text. So we can so here this is empty. When resetting, this is empty. Tie, and here the player wins. And this is not updating. Why is that? Set text. This is I have to cast this to text, so we have the text property, but we should check. This looks like a bug. That should work, but now like this it seems to be working. Circle wins, cross wins, and let's produce a tie. Okay, so this is it. This is what I wanted to do. And well, let me, for example, create a scene. So in game scene, this is a scene, and this is going to main function here. Well, in the init, maybe we can load the KTree, and in the main we can do everything here. Maybe we can even provide a model, so we can restart the game, and here we should use the KorGE config, I think, to provide the scene class, the entry point. We have to provide the module here. So Tic-Tac-Toe module, and here we have the size, this one, and the color, that is going to be this one. And we have the scene class, the main scene, that is going to be this in-game scene class. Can remove this. Okay, so this is our module. Let's make this an object, and this is probably not going to work because I have not mapped the in-game scene. Yeah, I have to map it here. Configure, map, prototype. So this is, and here we have this scene. Maybe when the game has finished, maybe we can just reload. We can get the scene container, and I don't know, maybe change to this one again. This should do the same effectively, because we are just recreating the scene. Let me try. Yeah, but the crosswinds is still there. Type. So let me check. We have this transition view, and this is the game itself. And when I complete the game, this is changed, but this text is not set. I have to check, but well, in the end we can put this code here, and now we have the in-game scene packets into a class. So this is encapsulated. So we have this, and then we can have a model packet here. So this code is now a bit better. This should be a scene, or models should be models, depending on the style here. Well, that's it. I think this is what I wanted to do, and well, this covers KTrees and the scenes, and how to separate models from views. So that's it. Thank you for watching, and see you in the next video.